it's called a dehydration synthesis, or you can call it a condensation reaction, which is what we call it in chemistry. Okay, so that's number 7 done. Number 8. Number 8, we're going to take an alkene and we're going to turn it into 1-ethoxyhexane. So we're taking an alkene, which is over here, and we're going to turn it into an ether. So similar to what we did is we're going to take our alkene, we're going to react it with water to make an alcohol, and then we're going to take that alcohol and add another alcohol to it to make the ether. So the parent we have to start with is a hexane. Because we want an alkene, it's a hexene, and because we want that ether group to be on the carbon, we are wanting hex 1-ene. So we're going to start with hex 1-ene. We're going to add water to it. Water requires concentrated sulfuric acid. So what's going to happen here? Your HOH, we're going to break this double bond. We want the functional group that we're attacking to go on C1. So the OH is going to go here, and the H is going to go there. So on the other side, we're going to have our OH here and the H from the water there. And now we have hexane 1 all. So we added water. We did not change the chain length or add more C's. So it's not a it's a hydration as opposed to a hydrolysis, which we'll get to later. So it's a hydration. And because we broke a double bond and added the components, it's also an addition. So that's the first step. Second step, we're going to take that alcohol with the OH on it, and now we have to add another alcohol. Well, we want it to be an ethoxyhexane, which means we have to add an ethanol. So we're going to do the same thing we did up above. We're going to remove the OH from the parent. We're going to remove the H from the alcohol we added. On the other side, these are going to come together. So like that, or you could draw it straight out. It really doesn't matter. So there's my 1-ethoxyhexane. And I'm also going to produce water because I've eliminated, without replacing or substituting, the H and the OH come off to make water. And then this open bond on the O of the smaller alcohol connects with the open bond on the C of the parent, and that's where your 1-ethoxyhexane comes in. So we have an elimination here because we got rid of the components of water. And the other thing we have here is because we dehydrated and synthesized, we have a condensation reaction. Okay. All right. So let's go to number 9. So in number 9, we're going to take methoxyethane, which is an ether, and we're going to convert it into methanal, which is an aldehyde. So we are going to go from an ether to an aldehyde. So to take the ether, we're going to add water, and we'll make 2 alcohols. We're going to take the parent alcohol, and we're going to undergo a controlled oxidation to turn it into an aldehyde. So let's draw this. So 1, 2. So there's my methoxyethane. And the first thing I'm going to do is add water. So that's my H to the OH. Now the parent This here is going to be the parent because it's the longer chain, which is what it's named after. So the OH is going to go to the parent. So this is going to go to the parent. So on the other side, I'm going to get an ethanol. Sorry, that in pink again. I'm going to get an ethanol, and then I'm going to get a methanol, the H from my water. So what happens is I come in and I cut the compound there. So between the parent and the methoxy branch. The parent gets the OH, which makes ethanol, and the branch gets the H. So this H goes to the branch, this goes to the parent, and so I make two alcohols. This is the one that is going to move on into step 2. So because I'm taking water this time and I'm cutting the compound, I'm breaking it up into 2 smaller compounds. So when you go to your list here, hydrolysis, the breaking of bonds in a larger molecule by adding water to form 2 smaller ones. So hydrolysis is the cutting of a compound with water. So this is a hydrolysis. And because I've added an OH to one compound and an H to the other compound, it's also an addition reaction. It's not a substitution because we didn't substitute one atom for another and we didn't eliminate anything. We don't have any byproduct here. Okay, so, and the last thing is whenever you add water, you need concentrated sulfuric acid. Second step, we're now going to take the parent alcohol, which is our ethanol, and this time we're going to undergo a controlled oxidation. And let's use the permanganate ion in concentrated H2SO4. So here's what's going to happen is we need to make an aldehyde. So the first thing we're going to do is we have to enrich the CO bond. So we're going to eliminate this H. We're going to eliminate this H. It doesn't matter, this one or this one. So we know we're going to get water on the other side because those H's are going to pick up some oxygen from our rich source of permanganate ion. And then we're going to form a double bond in between the C and the O. And now I have ethanal. In terms of types of reactions, we have a controlled oxidation because we've added a rich source of oxygen slowly, and we've eliminated 2 H's by having them react with an O. We've eliminated water on the other side. So this is an elimination. And because it's water that we eliminated, this is also called a dehydration. So this is an example where there are 3 types of reactions. Elimination is one of the 3 starred ones, and then you have a controlled oxidation, but you also have a dehydration here because we produced water on the other side. And I think I may have forgot that. If you just go back to number 6, I'm sorry, this is my fault. It's the same thing here. When we made our ketone, we added our rich source of oxygen to have a controlled oxidation. We eliminated water, but because it's water that we eliminated, we also have a dehydration. So there are 3 of them with that one. Whenever you produce water on the other side, it's either going to be a condensation or a